Allah Rahman Rahim. So today we will continue our session of database normalization, which we have discussed in the last lecture regarding various constraints and FT definitions for basically the dependency definition, normally represented as functional dependency, FDs. And on this slide, we can see one example to see how those dependencies you can check whenever you have a given table or the values or the data. So let's see this table teach, and there are three attributes: teacher, course, and text. And now apply that definition of functional dependency and to see which of the dependencies exist. For example, text implies codes or text determines codes. Let's check it. Text determines codes. So this is the value of text, and here you can see yes, this is true because for every value in the text column you can see are different values and they determine different courses. So that FD holds over here because according to the FT definition that persist in this particular table. But let's suppose if I want to see whether course determines text, this one is possible or not. So data structure determines Bartram, data structure determines Horowitz. So the same value determines two different values in the next column. So here that definition, the definition of the FD violates. So therefore, I can say that course determine X is does not exist, although text determine codes do exist. Now we can see whether teacher can determine codes. We can see Smith. Smith determines data structure. Here, Smith also determines data management. So it means it violates the definition of the functional dependency. So teacher determines codes will not exist. So in this manner, we can also determine whether those functional dependencies hold or not. This is one example for you. Just try it out on your copy. Have this table and see whether various dependencies do exist. There are four attributes. One is A, B, C, and D. There are four attributes. There are various values which are assigned to these attributes. I can just take one example, and then all other examples you can do it in your copy based on the given definition and practice. So here I want to see whether A determines B holds or not, whether this FD holds or not. So A1 determines B1, A1 determines B2. Again, it's a violation. So it means that it violates the definition of the FD. So A determines B does not hold. Now you can check A determines C, A determines D, and other dependencies as well. So when we talk about normal forms, here in this section, we will see that what are the normal forms which are based on the primary key. And here we will discuss the normalization of relation, what normalization is, the use of normal forms, definition of keys and attributes, and participating in keys. Then we will have the explanation of first normal form, second normal form, and third normal form. So normalization is what? Is a process of decomposing unsatisfactory bad relations by breaking up their attributes into smaller relations. So you can say that in database, normalization itself is a process. What type of process? It is a process which removes all kinds of anomalies which exist in any relation. And what are those anomalies? Either that anomaly can be an insertion anomaly, deletion anomaly, or an update anomaly. So what happens in this process? When we apply this process of normalization, so whenever there are any anomalies in the given relations, so normally that relation or table decomposed into two or more relations. That is the output whenever we apply the process of normalization. And what is a normal form? So normalization is a process. What is normal form? Normal forms you can define a condition using keys and functional dependencies of a relation to certify whether a relation schema is in a particular normal form. So I just said that normalization itself is a process, and that process involves various normal forms. These normal forms are named as first normal form, second normal form, third normal form, Boycott normal form, fourth normal form, and even we have a fifth normal form. So there are various forms. So we have to review all the relation. Every normal form describes its own condition, and we will check every relation that whether it holds the first normal form. If it is not in the first normal form, then we have to normalize it. Let's assume it is possible that relation is in first normal form, it satisfies the condition, then we have to check for the condition for the second normal form, and we will see that whether the relation holds second normal form. If relation also holds the second normal form, then we can look for the third normal form. So every normal form defines its own condition based on the key definition in the relation and the FDs. FDs refers to functional dependencies. So we have to apply normal forms one by one onto those relations to make them normalized. And in this process, as is in the previous definition, we have explained the process that whenever we apply the process of normalization, normally it decomposes the relation into two or more relations. So normalization of normal form, we have already introduced the various normal forms, and we will discuss these normal forms in the next slides. So normalization is carried out in practice so that the resulting designs are of high quality and meet the desirable property. Now the question is that whenever we are designing databases, or whenever we are designing the database schema, we have to make sure that the schema does not have any kind of anomalies, or you can say the schema must be free of all kinds of anomalies. So normalization is a one way to eliminate all those anomalies from a relation, and obviously the objective is to have a high quality or desirable design for the given database. So that is why we practically we apply the normalization, and practically we use the normalization. The practical utility of these normal forms become questionable when the constraints on which they are based are hard to understand or to detect. So obviously, whenever we apply this process, it is always difficult whenever we have various kinds of constraints which are not identifiable, or it is not clear in your design schema. Then of course it is difficult to apply those normal forms. And what is the desirable task for the database designers? So all those database designers who want to develop a database schema for any given problem in any given domain, so what they need to do? They need to normalize the highest possible normal form. So we have to achieve the highest normal form. Let's assume we talk about the fifth normal form. So you go with the first normal form, to the second normal form, to the third normal form, to the BCNF definition, fourth normal form, and then you will reach out to highest normal form. Let's suppose it is fifth normal form. So fifth normal form is actually a special case, but generalized normal forms are up to fourth NF or fourth normal form. If we have a time, we also discuss the fifth normal form. The denormalization, what is denormalization? So if there is normalization, it means there is also the concept of denormalization, the process of storing the join of higher normal forms relation as a base relation which is in a lower normal form. That is the concept of denormalization, because when we normalize those relations, what happens? It decomposes into two or more relations. But let's assume if we combine or join all those relations together, we can have the base relation. So that is the concept of denormalization. We already have a definition of a key and a super key in our previous lecture, so I skip over here. the definition of the key and the super key. And here we talk about okay, first normal form. So please try to understand the concept of first normal form. Any relation you can, even you can write in your copies as well, that any relation is in first normal form if it fulfills the basic properties of the relation. And what are those basic properties of the relation? That every row is distinguishable. You can have a null values within those attributes. There is no ordering of tuples, there is no ordering of attributes, and the concept of atomicity principle. So if we have all those basic properties in any relation, so by default it is always in first normal form. So it means there is no repeating group of information in any tuple or a group of tuples within the relation. So if there is the repetition of information, then it means that it disobeys the first normal form. So if it is in first normal form, it must disallow the composite attributes. So here we'll not talk about composite attributes, or will not talk about composite keys as well. We talk about multi-valued attributes. This is also disallow when you talk about first normal form. So here we will not talk about multi-valued attributes. Multi-valued attribute means an attribute might hold more than one values, which principle is actually the atomicity principle, because we had this discussion earlier on that whenever we have values in a relation, it must follow the atomicity principle, or the values must be atomic. It means at every row column position there must be only a single value. There is no list of values or multi-valued attributes. Nested relations is also disallowed when we talk about first normal form. Attribute whose values for an individual tuple are non-atomic, and actually these are nested, so connected to another relation and so on and so forth. Considered to be part of definition of relation, of course, most relational database management system allow only those relations to be defined that are in first normal form. So in other words, it is very simple to understand that if any relation holds the basic properties of the relation, we can say that relation is in the first normal form. Let's see the example over here. Let's see, you have the first relation. There are three relations which are there. All these three relations are actually a department relation. So let's see what is A. You see the A relation. In the A relation, we are having four attributes. You can see over here, one, D name, D number, manager SS, departmental manager SSN, and departmental locations. So department number is a key. So from D number, a D name can be determined. From a D number, department manager SSN can be determined. And also from D number, that D locations can also be determined. But you see here, it is represented with a dotted line. What does it mean? It means that it does not directly determine by the D number. Actually, it depends upon the department itself. So where is the location? So normalization into one NF, then you can see a relation schema that is not in 1F. Then in B, you can see that you have various values in D name, and you have some various values that you can see 5, 4, and 1 department numbers, SSN. And here you can see in the location, please see here in the first tuple, here you can see that it has more than one locations. So these are multi-values. So if these are multi-values, it means this relation cannot be represented as cannot follow the definition of the first normal form. So it violates the definition of the first normal form. So it means it violates the definition of the first normal form. So we have to convert this into a first normal form. So what we can do, so, okay, what is the solution? But how we can do this? Because the location value is does not dependent on the department number exactly. So therefore, in the resultant table, what happened? Department number and department location basically combines together to form a primary key. So now here we have the D number and D location. So here every tuple can be easily identified because every tuple will be discussed with reference to the value of D number and D location. So here these values will not repeat: 5 and Belair, 5 and Sugarland, 5 and Houston, 4 and Stafford, 1 is Houston. This is disallowed. So this B relation is disallowed. This will not fulfill or does not fulfill the definition of the first normal form. So that violation can be corrected in the C, and now this relation you can say is in the first normal form. And similarly, we have another example where we have the employee project relation. And in the employee project relation, you can also see in this relation that we have the SSN number, E name, the project number, and hours. So the hours and the project number and the employee. So here we have to resolve it. How we can do it? Because employee works in more than one project, so we have multiple values here, we have multiple values here, you can see there are multiple values here. So what to do? So it is better to split the table or split the relation into two relations. Here you can see one is the SSN and the ename, because SSN determines the ename, and SSN and P number combines together determines the hour. So instead of having this one table which violates the definition of first normal form, we can decompose this relation into two relations. One is called employee project 1 and the other one is called employee project 2. So by applying this definition, we can normalize. So this is, you can say, is a bad design, okay, because it violates the definitions of normal form, and also there in this table we have anomalies. So to correct this, what we have done, we have decomposed this into two relation. One is called employee project 1 relation, second one is called employee project 2 relation. Second normal form. So you can again write the definition for the second normal form. If you have a copy with yourself, please write it down. A relation is in second normal form if and only if it is in first normal form. It means if you are checking the condition for the second normal form, make sure that the relation is in the first normal form. So relation is in the second normal form if and only if it is in the first normal form and all the attributes must be fully functionally dependent on the primary key. All the non-key attributes must be fully functionally dependent on the primary key and not the part of the key. So normally the second normal form is applied wherever we have a composite key, because whenever we have the composite key, remember, when we have the composite key, it means our key attribute is composed of two or more attributes. So all other attributes other than that key attributes are called non-key attributes. So we have to see whether all the non-key attributes are fully functionally dependent. It means they must be dependent or functionally dependent on the whole key, not the part of the key. So let's see how this definition can be observed. For example, in the previous table, the employee project table, the SSN number and P number, this is composite, that determines hours. This is true because hour cannot be determined through only P number. It is not possible. And hours cannot be determined only from SSN. So hours is dependent on both these values. So it means you can say that hours basically is fully functionally dependent on the whole key or the primary key. In the next definition, we have SSN comma P number determines ename. No, this will not fulfill the second normal form definition or a constraint. Why? Because actually ename is only dependent on SSN. Ename has nothing to do with the P number. So it means this is not, it means this e name is not fully functionally dependent on this key. So it means this violates the definition of the second normal form. So that is the concept which is called fully functional dependency or a full functional dependency. A relation R is in second normal form if every non-prime attributes of A in R is fully functionally dependent on the primary key, as I have clearly discussed in the previous slide and you have seen few examples. So if that is the case, let's suppose, and there is a violation in the second normal form, or you have observed the violation of the second normal form in your problem or in your design, then again, what is the process? You have to decompose the relation. So you will decompose the relation into two or more relations. So let's see the example carefully to understand the concept. Here we have the table, that is employee project table, and here we have a key which is SSN and P number. So they both determine our, this is true, but e name is only determined by SSN. This is FD2. What is FD3? With P number you can determine the P name, and from P number you can determine the P location. So these are three various kind of functional dependencies which exist in this relation. So according to the second normal form, there is a violation. Why? Because e name is not fully functionally dependent on the key. It depends on the part of the key. Again, violation. P name is not dependent on the whole key, only depend on the P number. Again, it's a violation. So it means in this table, which is shown to you right now in the A part or in the A diagram, there you can easily see the violation. So what is the solution? So the solution is that the attribute which depends on both the key attributes or a composite attributes will come with this, that it SSN, P number and hours. E name is only dependent on SSN, so we make it a separate table, and P name and P location basically dependent on P number, so we put it in a separate relation. So here we have three various relations representing FD1, FD2 and FD3. So in that manner, we have achieved the normalization process. So you can say this A is actually not in the second normal form. You applied the second normal form and you have decomposed the relation into three relations now. And now there is no anomaly in these three relations. Now you can see another example over here in the B table, which is a separate example, that we have an employee department relation. Here we have the e name, SSN,